let's get started. This is going to be a down and dirty video on how to use an Arduino Nano 33 BLE Sense board to connect to your iPhone. Now we're going to caveat this. Your iPhone is not going to see this directly, but your iPhone will act as a conduit for an application that we're going to install. And we're going to go through every step, and it's going to be fairly quick. So if you need to, stop and come back, watch the video again. But there's a lot to it, but when it's all said and done, it's actually pretty straightforward. So let me do a quick summary here. The first thing we're going to talk about is the actual device. We're going to show you where to go get it. We're going to talk about the client software. Think of this as a client-server operation where your Nano is providing a service and the client is an application on your iPhone. So the product that we're going to pull up is light blue. There's any number of products that you can use, but we're going to use light blue for our example. The IDE, the software development program, which is going to help you develop the code and install that code onto your board. We're going to show you where to get that and how to get it installed, and then we're going to go through configuring it, because right out of the box it's almost there, but it does, nothing works, right? You've got to have the right libraries downloaded, and once you do those three downloads, you can use one of the examples and create a demonstration that will connect this Bluetooth device to your phone, to an application on your phone, and you'll have connectivity that will allow you then to go from there. Once you can sort of see the mechanics of it, hopefully then you can expand upon it to do whatever it is you want to do. So here you can see that this device is transmitting via Bluetooth to an application. If we go into the settings, notice there at the bottom that it doesn't display. So what's happening is the Bluetooth is tunneling through the iPhone's the transmission from the Nano is tunneling through the Bluetooth connectivity features of the phone, and the light blue is able to piggyback off of that system and detect it and display the results. So let's start here at the top. Let's go look at the device. You can see here, this is a Nano. It's about the width of a dime. It's probably about 2 inches long, and of course it's wafer thin. It's probably 1/8 of an inch thick, top to bottom. You can find it out on Amazon, around 30 bucks. There's probably cheaper. Specifically what we're talking about is the Arduino Nano 33 BLE Sense. There's a variety of boards. There's an Uno, there's a Nano, there's a Nano 33 BLE, etc. So the stuff that we're going to go through today is going to focus on the 33 BLE Sense, but most of the activities that we're going to do here will correlate to any of these Bluetooth enabled boards that Arduino is putting out. So before we go any further with the Arduino side of things, we're going to proceed over here momentarily to the light blue side of things. On your phone or whatever device that you're going to use as your client, the thing that you want to see the transmissions from, ideally you would like to be able to go into your Bluetooth settings on your iPhone and scroll down to the bottom and see, there's my application flashing right there at the bottom. Only certain things are allowed to be displayed in the settings Bluetooth features of an iPhone, but other features allow, other applications are allowed to piggyback, if you will, that the phone will receive the Bluetooth and pass the information on to the applications that are open. And if one of those open applications happens to know how to talk to it, it'll say, golly gee, there's my service, and you can connect to it and use it. So for example, a foot pod if you're doing a fitness application, a foot pod won't show up necessarily in the iPhone settings under Bluetooth, but it will show up under Garmin or under Zwift or some of these fitness applications, because it is a running pod. It's a running cadence sensor, and so it's designed to talk to certain kinds of applications, and those applications know who they are. So when you're on your phone, you open up Garmin or Connect, or you open up Zwift, it goes to the Bluetooth mechanism on your phone and starts listening for the services. It says, golly gee, there's the service that has the foot pod, and then it connects to that foot pod service and displays the cadence for you. So this is going to be our user interface on the phone. Now the way you go, just go into your your app store, type the word light blue, no space, no spaces there. It'll have this blue fist, and install that on whatever is going to be your client. Now I'm going to show you a video of it physically on the phone later, but this is where you would go. So this one's Mac, but you can get it on iOS, you can get it on the Android platforms, etc. The next thing you're going to need, so now let's come back to Arduino. Okay, this is their home page, and there's ways to buy, there's ways to donate to help them do their thing. We're going to skip, down here. There's all sorts of good stuff up here: the communities, the blogs, the forums, etc. I'm not going to get into that in this video. We're just going to go straight to what you're going to need, and that is to download the code onto your PC. Now I'm using a Windows PC, so I'm going to come in here, and I'm going to come over here and click on the Windows app for Windows 10. I can also go into Windows Store, and I can do a search for Arduino, look for the Arduino app here with the plus and minus sign on it, and install it that way. So there's multiple ways to get this product installed on your machine, but you're looking for the Arduino IDE integrated development environment. The next major thing we're going to talk about will be Arduino BLE, the Bluetooth Low Energy Library. There's a website, or there's a page here. If you come to Arduino, do a little search for Arduino BLE, you'll find this, and this is where you're going to find the BLE class. For those of you who are not programs, these are all the features, all the capabilities, the characteristics. We call them properties and methods. And eventually you're going to if you're not a programmer already, you will have to learn some of this stuff, but this is kind of an overview, and don't worry about all the details here on the right. Just read through this, and it explains some of the terminology. For example, the concept of peripheral devices and central devices are displayed here, and it goes through a very good description of what it is. I like to think of it in terms of client server. The server is going to be the thing providing the service. So they're going to be the foot pod that's emitting the details or whatever. We're going to do a battery monitor scenario to monitor the battery of the device and send it to our phone. So the sender is the server. The receiver is the client. So in a client server environment, the server provides data to the client does something with that data typically. There are some, there are read-write capabilities. That's way beyond what we're trying to do. We're trying to get you from 0 to 60 in just a few minutes, okay? So now the next step is we're going to jump straight into the IDE. Now for those of you who are not real familiar with, development environments, when you first come in, it's going to look something like this when you first open it up. So after I've installed it, I can come down here and I can come up into my recently added, and I can launch it, and or I can launch it from the App Store. But the point is, once you launch it, it comes up with a very vanilla thing. There's a setup section to the code, and then there's a looping section. This runs one time, and this runs once the service is up. It runs repeatedly, and it just goes, once back over it once, twice, 3 times, etc., and keeps recalculating, retransmitting whatever is appropriate. Now it's very vanilla. This is what's known in under the examples. If we go here under under examples, file examples, this is what's known as the bare bones, and I don't even remember where they put it, but it's the bare bones example here. I'm not going to waste any time looking for it. There's a whole set of templates right here. Okay, so you'll be tempted to come down here and say, gosh, you know, let's jump right in and pick one, and here's a battery monitor. Let's jump one in and pick one. So let's do that. Let's pick an example. I don't know, bridge, Ethernet, internet, whatever. Poof. Notice that it opens another window. That's a little bit odd. I'm not entirely sure why it can't open it within the same window, but this is just another copy of it, and this may or may not work. The problem is that some of these examples are board sensitive. Remember, we have a Nano 33, so before we do anything else, we're going to come back here. We just open it up. We're sitting in this kind of very basic level here. The first thing we're going to do is make sure that our board is installed. So we're going to come up to Tools. We're going to come over to Boards. Now you can see it's already selected Arduino Nano 33 BLE, but that wasn't there when I first installed this the IDE. It was, you know, very vanilla. So I had to come in here and I went to Board Managers. Okay, then I'm going to type in Mbed, M-B-E-D, hit enter, and this one happens to be happens to support the Arduino Nano 33 BLE, and so right now I can't install it. It's already installed, but I would remove it. I'm not going to remove it because I need it. So when you do this, you'll have an install button over here. You'll click this, and then it's going to do a download of, basically think of this as putting all the drivers onto the your local machine. It loads them into the Arduino folder so that all the drivers and all the compiling information is available to talk to your board. Now this is actually, this took a fair amount of time because it's going to download a variety of boards, and once it's done, you're going to come down back into Tools, and you're going to come to the Boards section, and you're going to go find the Arduino Nano 33 BLE. Notice that it's under the Mbed OS boards. These were some of the, I think this was the default that came with it. This is what we just installed. Remember, we typed Mbed, and it's for NRF 52840 series boards. These are the options available. So I'm going to click this BLE, and then that's what shows up here as my board. Now, at this point, if I connect my device, and I'm going to show you a photo of it, a video of it, I'm just going to take a small USB device. It's a, I don't know, micro or nano connector or whatever it is. You connect it to a USB port, and as soon as you connect it, it's going to have a little green LED, which I'll show you in a minute. That green LED will come on, and that means it's communicating with the IDE. So if you come in here, by default, it won't have anything selected. It'll look, well, it won't let me unselect it here. There will be nothing selected. It'll say board, Arduino Nano 33 BLE, and the port will be blank. So you have to come in here and choose the COM4. Now in my case it's COM4. In your case it might be COM6. The point is, whichever one has Arduino Nano 33 BLE to correspond to your board, make sure that that's the one you select. So at this point in the game, we're about halfway to successfully connecting our device. We've got the drivers, if you will, installed for the board. So now let's go out and add the libraries that will allow us to talk to using Bluetooth, talk to our client. So the next step is to come in after we've loaded the boards, and we're going to load a couple of libraries. The two main libraries we're going to load is going to go to Sketch Manage, Sketch Libraries Manage. Let me do that again. Let me do that again so you can see it. Come into Sketch, Include Libraries, Manage Libraries. And the first one we're going to load is the Arduino BLE. Okay, you can see that I've already installed it. Once again, you can select the latest version, or you can select an older version if you want, but I just selected the version 1.2, which is the current, hit the install button, and it installed the files. Think of these as include files for those of you who've done web development. You know, these are pre-canned sets of, for Windows users, this would be like a DLL, right? It's going to download a library of capabilities, and it's going to put it in the Arduino folder, and then when you call on those functions, it'll make sure that they're included at compile time. The second one that we're going to look for is, and this BLE one, the Arduino BLE one, is the one that will actually do the communication to your phone. The next one we're going to do is, while we're here, is LSM9DS1. We're going to add this board here, Arduino LSM9DS1, because this is what's going to allow you to work with your accelerometer, magnetometer, gyroscope, etc. on the 33 board. So let's say, just for the sake of discussion, you want to do something, I don't know, you know, a pitch, roll, and yaw kind of scenario, or you know, acceleration on X, Y, and Z, and you're going to send that to you know, a database somewhere on your phone or whatever. The point is, if you want to activate all these built-in features that are on this board, you've got to be able to talk to the board. Remember the tools, when we loaded the board itself, that sort of was the base communication. Well, this is the thing that's going to talk to the components that are built into the board. So we've loaded those two libraries. And if we come back now real quickly and review where we were, we bought our device, had it show up, we installed Light Blue on our phone, we downloaded the IDE, and then we installed the embed to have the board drivers, if you will, and then we installed the BLE library and the LSM9DS1 library so that we can do more advanced things with the accelerometers at a later date. Now we're just about done. Before we go over and physically look at this, the next step is going to be to actually use to build something. So we're going to go into examples. Well, now, among other things, notice that there's a folder down here for Arduino BLE. Well, these are some of the things that got loaded with that library. If we come back up here, these are some of the things that we, the gyro and the accelerometer, gyro, and magnetometer that got downloaded with that particular library. So the first one we're going to do is come down to the BLE, because remember, you want to see, let's face it, what do you want to see? You want to see your device talk to your phone. That's what you want to see. From there, you'll work backwards to whatever it is you want to do. So we're going to go to the battery monitor example. Notice that it pops up a new window. Not entirely sure I understand why it can't open up in the empty window, but anyway. If you have the correct drivers for the board and the correct libraries installed that we just done, if you do a check here, up here at the top, this is how you communicate. We're telling it to talk to this board on this COM port, and we're going to use the Arduino BLE library, and then various other, the LSM9 one is not going to, we're not going to use that in this example. We'll use that in another example. But this one's the one that's going to talk to your phone, the Bluetooth portion of it. The other is going to be an accelerometer example. So if we come up to the top here, the way it works is you can do basically a check of the code. Think of this as a compiler, a pre-compiler. It'll compile the code, but it won't actually push it to the device. And this can take a few minutes depending on how complex it is. Notice in the lower right here we have a status bar to kind of give us an idea of how long this thing is going to take. I'm going to pause it. Now as it goes, you're going to get a variety of these messages down here in the window that are in orange. Generally speaking, I don't like getting a lot of, you know, it's sort of nice to know, think of this as the disclaimers. Well, you know, something might go wrong because something's not exactly entirely right. If it doesn't compile, it'll actually highlight a row, and it'll highlight it with a light red background, and you won't be able to compile it. Notice here at the bottom, it finished, right? It got done. If you get these 2 lines of white code at the bottom of all this orange crap, all this is just, you know, ass covering disclaimers, okay, as a general rule. Now, I'm going to do something here real quick. I'm going to come back. See, this is the service name that we had. I'm going to change this to Xanadu. Why? Because, look, I love Olivia and John. What can I say? Okay. But so that when we go into the phone and you're looking for a service and you see battery monitor, how do you know that it's actually my battery monitor, right? Maybe it's someone else's battery monitor. The next button up here to the right is the arrow that basically compiles it again and pushes out. So you don't have to do the check, but it's a smart thing to do the check. And notice that it doesn't put the disclaimers here. It goes through, and then you can see that it's starting to load. Okay, and it'll take probably about 12 seconds or so on average. Okay, now for some reason after it compiles, it always drops the COM port. Okay, so this is kind of what I was talking about earlier. Remember, you saw it already had COM4 picked, but if it's empty, you've got to come in and pick it. Now, I'm not sure why, but after it connects, it always seems to drop the port. So come back in, make sure you're back in this configuration, and then come up here to the upper right and click on this thing called serial monitor. Now notice that it's going to pop up a COM4 serial device. It's basically, think of this as an old serial printer. It's sitting there waiting. Now I'm going to go out onto my phone, and in a minute I'm going to make a physical video of the phone so that you can see what's going on. But I'm going to come out to my Bluetooth or my phone, and I'm going to launch the Light Blue application. Now once Light Blue comes online, it's going to start scanning, and it's going to start looking for various and sundry things. So let's see what happens. Now I just picked I just connected to it inside the app, and it says connected, and it's showing me battery level here, and let's see, advertised data, there's Xanadu. Woo-hoo. Okay, and you can see that it's sending data. The Nano is sending the data back into the serial port of the computer, so it's kind of the gateway between the phone and the computer, right? It's sending stuff to the phone, and then it's telling you what it's doing. And so you can see that the time is stopped here. It's sending stuff periodically. I can push a button over here that says read data again, and it will basically cause it to trigger. But now I'm going to close this, and I'm going to show you on the phone what it looks like. I'll be honest, I thought that the service name was going to be Xanadu, but it actually calls the service Arduino, and then one of the properties inside of it is Xanadu. Okay, so notice that I just disconnected because I'm going to take a video from scratch, and we got the feedback. The Nano is telling us that it disconnected from the Light Blue client. Okay, so I'm going to stop the video now, and I'm going to make a external video so you can see what's going on the phone, and then we'll wrap it up. Okay, I know this isn't the greatest picture on the planet, but over on the left you can see the Nano. You can see it's not very big. When it's connected with the USB cable to my PC, there's a green LED flashing over there to indicate, and there's a little white button in the middle here, which is the reset button, and so it's plugged in, and that's what's talking to the serial device. When I published it, the instructions came out from the computer, and then when it started operations, periodically it sends feedback into that serial port telling the computer what it was doing. Now over on this side, you can see I'm in the my iPhone. I'm in the
App Store, and I look for light blue, and this is what it looks like. It's, you know, got the icon there. It's already installed. I'm going to go ahead and open it. Okay. Now notice it starts looking. I've got a Samsung TV. There's the Arduino. This is where I honestly expected to see Xanadu, but when I connect to this, okay, you notice it says connected. If we come back over, I don't know if it's going to show up or not. If we start looking at the feedback from the Nano onto my PC, you can see that it's connected again. So now if we come back to the phone, and let's drill down into some of the details. And somewhere in here earlier I saw the description. Where'd it go? But I saw it earlier. There we go. Okay, so there's Xanadu right there. I don't know if you can read it or not, but the second line, it says the local name is Xanadu. The device is connected, and it's sending whatever the simulated battery value are. Now I just disconnected. If you come back over here, it says I disconnected. So here you can see that this device is transmitting via Bluetooth to an application. If we go into the settings, notice there at the bottom that it doesn't display. So what's happening is the Bluetooth is tunneling through the iPhone's the transmission from the Nano is tunneling through the Bluetooth connectivity features of the phone, and the light blue is able to piggyback off of that system and detect it and display the results.
Okay, now that we've shown how to create a service that connects the Nano to your phone, let's do another quick example of how to use, for example, the accelerometers, the gyros, that sort of thing. So in this one, I'm going to come back in here and I'm going to go into examples. I still have my Arduino selected in COM port 4. I'm going to come over here to File, Examples. Now I'm going to come down to that LSM9 thing here, and I'm going to come in and pick one of these simple accelerometer examples. Let's use the simple accelerometer. Okay, let's come up here, confirm that everything carried over, everything opens in a new window. Now, when I push this out this time, it's going to overwrite my transmission, my BLE transmitter, right? I'm basically going to have one program at a time. So eventually I'm going to want to take the BLE, the Bluetooth transmission, and the accelerometer piece here, and I'm going to want to put those into one program so that both capabilities exist. But for this demo, we're going to go ahead and start pushing this out, the simple accelerometer case. While we're waiting, notice that here's that library that we downloaded when we went up to the library manager. Okay, you can see that it pushed out and it's loaded onto the device now. I'm going to come back in. For whatever reason, it drops the port every time you do the push. Reselect so that we have COM4, and then I'm going to come back over to my serial monitor up in the upper right here, and I'm going to launch that. And you can see that it's reading data from the accelerometer. Now I'm going to move this thing around a little bit, and you'll see that the numbers are changing from plus to minus, negative numbers to positive numbers. Really exciting stuff, right? Without getting into all the gory details, you can take there's a couple of examples out there where you can go out and you can pull data and do things with it. So here's the accelerometer data, the X, Y, and Z raw data. And what I did is I came into Excel. The way I did this, just to sort of, full disclosure, I clicked on this, I start getting some data here. Okay. At some point when I'm ready, I push the little reset button, the little white reset button on the device, on the Nano. That disconnects it and stops the COM port from coming. Then I click anywhere in here and hit Control A for select all, Control C to copy, and then I bring this data over in and paste it into Excel, clean it up a little bit. And then I plot it. And notice that what I was doing here was, in this example, I took the accelerometer and I basically did 10 cycles with it. I just moved my hand back and forth 10 times to see what would happen. And sure enough, if you look at the x-axis, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 peaks, right? So somewhat sine wave-ish looking thing. The y and the z-axis were not quite as clear. You might be able to break something out there. But, it is what it is. The point is, this is usable data. I might have to put a line fit through it and do some, some sort of data smoothing to it. But this is data where I can find the peaks of each of these cycles, and I could get a cadence or, an RPM, if you will. I used another library. I found one online. Some guy did a great job of Madwich, M-A-D-G-WIC. Okay, so if you come into libraries, go to Manage Libraries and type in the word MAD, you'll find the Madwich library. Okay, I installed this Madwich library because what it does is it takes accelerometer data and gyro data and converts it to roll, pitch, and yaw data. Okay, and then I ran that example. So let's go out here, desktop. Here's my IMU data. If we load that one, this one uses the LSM9 DS1, and it also uses Madwich, and it goes down here and it pulls the accelerometer data. And I'm not going to get into all the gory details, but it uses the IMU to get the acceleration data, and then it goes out and it gets the roll, pitch, and yaw from this guy's library. I don't know who he is, but it's a really cool library. Now, same thing. I ran, deployed it to the device, clicked on the serial monitor, cut and pasted the data over here, and these were the results from the yaw monitor and the roll monitor. Notice that this is very clean. I can get a definite RPM out of this because every time the thing would, in this case, roll. Imagine that you had this device on an axle and it was rolling, twisting about the axle. Every time it goes through, the 0 degree point, it goes from 360 down to 0 again, and then as it spins around the axle, it builds back up to 360, and then it goes to 0. So you can get a perfect example of how to get a cadence off of your axle. Here's one where I did it in yaw, similar. These have usable data in pitch and roll, but when it comes to knowing exactly when the RPM, the revolution occurs, when you have this, 0 to 360, 0 to 360, you know that it's popped over the top of the arc. And from this point right here to this point right here represents one revolution. So this is an example of the data that can be, sucked out of your Nano. And I haven't done anything. I haven't, gone in and explained to you any of the code. That's beyond the scope of this. This is about, kind of giving you optimism that you can get there. This is about saying, the very first night that you get your Nano, you will be able to talk to your phone. Yes, it's limited. Yes, it's only the battery information. You'll be able to get accelerometer data, X, Y, and Z accelerations, and roll, pitch, and yaw headings if you load those libraries that we just talked about. And then from there, you can take that data and start going out and figuring out, well, what the heck? What's this thing? Serial begin 9600. Well, that's the baud rate, right? That tells it how fast to communicate. Here are the acceleration variables, the floating point values for the acceleration variables, and the floating point values for the gyro values. These values are going to be shoved into the IMU. And from the IMU, you're going to be able to get the roll, pitch, and yaw. So I'm not going to go in any further into the code, but in this little example, you've gone from literally out of the box. You've got your Nano, it's sitting in front of you, you don't know how to do anything with this thing. You should be able to confirm that you can talk to your phone and that you can get data from the accelerometers and the gyros that are built in using the built-in examples. So in closing, remember, we have two different scenarios. We pushed one at a time. We pushed the Bluetooth transmitter piece once, and then we overrode it with the gyro stuff, right? The IMU stuff. So in order to get them both to work together, let's say you want to send RPM out to some application, for example, you would have to basically ensure that you blend the code. You'd have to bring in not only the LSM, DSN, and the Madwick library, but you would also have to bring in the Arduino BLE. You would have to put in all the stuff that connects in the setup here. You would have to put all the stuff that connects the service. Okay, and so you would have to have a blended program that does the connectivity portion as well as reading the data and figuring out the data that it wants to send, and then use the BLE to transmit that data to your client. So this demo, we did two standalone things, and we pushed the software out, and at any given time the device could do one or the other. It could do the transmission BLE stuff, or it could do the accelerometer stuff. And obviously a more practical product would be something that blended those two together. But I'll leave that to you. This was designed to give you confidence that you could go and actually see something coming off of your computer, off of your device through your Nano onto your phone, and establish some connectivity and some confidence going forward. So best of luck. I do hope that this was helpful to you, and wishing you all the best in terms of getting the product that you want up and running as quickly as possible.